Hello and welcome back to another video on my channel, and today we're going to be doing an experiment I've seen before because I have done it before on the channel, but it is magnesium and vinegar experiment, and this time, as you may have seen before on channel 2, I'm going to be putting a balloon here over the top of the acid. So this one here, this is tartaric acid. You will not have seen this before on my channel, but I'll explain you for it in a second. Here we have got the vinegar, however, I'm giving it the proper name today, which is actually, as you can see over here, hopefully, acetic acid. Not acidic acid, acetic acid, and it's basically just vinegar, fountain of barley and extra ingredients, but it's close enough for experiment today. So the balloons we're going to be using, we're going to put them over the top of the test tubes, and when the hydrogen comes out of the test tube, we're going to be measuring the diameter of the balloon, the ruler back there. We'll write it down on a board here. So let's going to talk about how strong the acid is, because we've got the pH, universal indicator solution here. We're going to be putting this inside because it has a clear, no, it's not water, it is acid for each one. We're going to be putting this one, the vinegar, and also the acetic acid, in here, and we'll see if it's red, and that means it's really quite acidic. If it is green, then that means it is neutral, and which it shouldn't be, because that'll be water, and it definitely shouldn't be blue because that'll be alkaline. So firstly, we are going to put the universal solution, universal indicator solution, into different acids. So you can clearly see what it is to begin with. So I'm going to put indicator here, not too much though. We don't want it to completely ruin it. We don't want it to mix too much. Otherwise that could ruin the experiment. So just stir it a bit, make sure it's all in there. Right, so very close to the camera. Spot is here, you can see it. I'll put it against here to make it easy because it gets white. So that's really quite a nice orange there, nice orange. And just to make sure it doesn't change, just a tiny bit more, swirl it around. But yeah, it's nice, it's already orange there. And I'll point out the pH at the end of the video for that one. And for the, let's see, the tartaric acid, let's do the same. Put some indicator in. And by the way, it is the same volume of the acid for each one to make sure it's all controlled. And we're going to be using the same temperature too when reacting them, as well as the same time we're going to be reacting for. So you can see this one here. I'm going to say this is a bit more deeper here, it's a bit more of a darker colour, meaning that it's probably a stronger acid compared to the acetic acid. However, the real indicator to show that is going to be in a second when we put this in here. So just make sure this is all adjusted correctly with the equipment. We are going to now put in some magnesium strips, which you have probably seen before if you've been watching the videos here. Just normal magnesium strips, as you can see here. And we're going to put 3 strips into each acid. So first, let's start off with the acetic acid. I'm going to use the tartaric one, we're doing that in a second. So carefully, let's put this into here. Make sure that it's really quite far down, to make sure that we don't burn the cork that's on the clamp putting here. We want to make sure it doesn't get burnt at all. And make sure this is correctly aligned, like so. Bring that over here. Let's light this, methylated spirit burner as usual. Now we're going to put in the 3 magnesium strips and quickly put balloon over the top, just make sure it's like that. However, first, make sure I don't forget this, we need to get a thermometer.
A few moments later.
Right, now we have the thermometer here, quite a large one, to make sure it doesn't fall out, or it could cause this to fall out of its place. Also now got the pH scale, so it's easy to measure it against. So we're going to do pH first, since we've now got this. And if we look this against here, I'm thinking that is a pH 1. I'm going to say for the acetic acid. I'm going to say that is a pH. Yeah, pH 1. So let's get a pen here. I'll see in a second. I'll move it back in a second so you can see it properly. But that is a pH 1 there. And let's have a look for the tartaric acid. Now I'm saying that is definitely deeper. However, I'm gonna say that that is not far enough to be a 0 yet. So I am going to put that at a, let's say, a 0.8, because you can, yes, have decimals on the pH scale. So that's at 0.8. So, good. Now we've done that, let us go on to the next step, as I was going to do before. Let's start heating up the vinegar before I put the magnesium to start the reaction. So remember, this is the vinegar, or acetic acid, I'm not going to use a tartaric. I'm going to put here. If I'm getting the right way around, that'll be helpful. This is quite a low molar, so it's fine mode. It's not really that damaging if you touch it, since it's vinegar and you do actually consume it. So let's have a look. This can go up to, hopefully, let's see what temperature we put on here to use. So 75 degrees Celsius, as I've written on there. Let's wait until we get 75 degrees Celsius. We'll take the heat off and then start the reaction. We're doing this as a control method to make sure that the reaction is as close as possible, really. If it gets to boiling point, obviously, if it gets to boiling point, it can be quite dangerous. It'll be bubbly. No one boiling acid, really, at all, for obvious reasons. So we now have it at 45 degrees Celsius. Hopefully it will keep on rising. It is getting to go to 60 here. Always make sure to have the test tube well in place, otherwise it may fall out during this process, and that's the last thing we really want here, isn't it? So now it is about to get to 70 degrees, a tiny bit more. All we need, a tiny bit more. Don't let it get to boiling. If it gets to boiling, we'll stop immediately. And we are almost there. And there we have it. Right, should put this away carefully. 75 degrees now. Put the thermometer there. They're putting cold water straight away as well. If that's quite dangerous for the thermometer. Now let's quickly, carefully put the magnesium in, stirring rod to make sure it's really right in there. The vinegar around there. There we go, you can hear that reacting straight away. Make sure it's all in there, which it is. Now carefully put the balloon over the top. Try and make sure that it doesn't fall off whilst I'm doing it. Not be helpful or careful there. Make sure it's in place, otherwise it will fall out. There we go, now it's collecting the hydrogen. So any hydrogen released from a test tube now will be going into the balloon. And we are now going to quickly start the timer. I'll just get the timer here. The timer has now begun. So I have to stick it there, unfortunately. However, see there, it's on about 7 seconds now. So let's leave that there. Now I'm going to pause you. I'm going to keep on letting this balloon take in all that hydrogen. I'm going to measure diameter afterwards, and then I'll unpause you there, and I will show you how large this balloon has gotten after the 15-minute time period shown on here. So I'll see you then. Bye. Okay, so we have finally now stopped the experiment, and I have just measured it. I'll show you again now. So that is, and I'm bringing it up to there. So I'm pinching at the top of the well, the bit of balloon to blow into, I guess. And there is hydrogen in here. It might, as long as it is flopping down. However, that's because it's just enough to hold it up. There is hydrogen in here. Pushing it, you can see there is hydrogen there. Push it up to the top here, twist it on top a bit. You can see that it goes 55 meters, and that's complete to the sides. So, just get a pen. 55 millimeters for the, is it acetic acid here? I'll show you all afterwards as well. Of course, because you can't see from there. Now I'm going to go on to the stronger, or the pH has suggested, stronger acid. So let's carefully just undo the clamp, put it in here, put the tartaric acid in here instead. Now, let's do the same as before. Let us heat up the tartaric acid first before we do anything else. Just get the lights here, so. Go under there nicely. Put the thermometer in the tartaric acid. Let's just see it begin to rise. So, hopefully we can get this as well up to a temperature of 75 degrees Celsius. However, of course, if it gets to boiling point, it will stop immediately. Say for reason you tell it big bubbles coming up, not little ones, but little ones are fine. For now. So it's got to 40, that's 50 degrees now, 50 degrees. Keep on going, Make sure also to see how high temperature when thermometer can break, because that can be very dangerous too. This was a safe thermometer though, which is fine. So 62 there, going up, and we are at 70. And that is 75. There we go. Right, 75 now. Thermometer over there. Let us start the timer after we've put the 3 magnesium strips in. 3 is same as before. Same amount of volume in here too. So, put magnesium in there. Make sure it's all in there last time too. So, new balloon. Carefully. Over the edge, there we go, it's better than last time, isn't it? And start the timer, like so. This timer started, as you can see again, and I'll just pause you again now for 15 minutes, just like last time, see how much this balloon is filled up for, and hopefully we'll see a change compared to the other one, and it may be more, as the pH suggested earlier. So, I will see you in a second. Right, welcome back again for the final time. Now, I've been doing this for 15 minutes again, 15 minutes, so it's control variable. And as you can see, it's still flopping a little down there, and it's because I've given it only 15 minutes time compared to last time I've seen my video done before, given it a bit longer, and that means more time and hydrogen get released. As you can see, it's still bubbling down there, but it's a much slower rate. So, got the ruler here to measure it in comparison to the acetic acid, which I've done before, and this is of course the tartaric. Now let's have a look and see. So pinch up to where a base of it is, press it down. Right, that is over 55. As you can see, I put on 55 for the last one. That is 58 millimeters. So, right down there, and I'll show you basically now what the result here looks like. So, let's go to the results now. Let's move that table here aside and move the results back. So, now what you should hopefully be able to see here is, so let's go back to the equation first. So it's magnesium plus acetic acid makes hydrogen and magnesium acetate, which is pretty normal for one of these equations because you've got the acid, you've got the metal, and then you should add usually the acid kind of name, so acetic acid, so that means it's going to be magnesium acetate. Of course, you've got the actual symbol formula here, magnesium plus 2CH3, then of course you've got the acid, which is COOH, so COOH, and that creates magnesium and then CH3OH and all this like that. And then, of course, we have got control variables, as I mentioned before. Temperature for the experiment was 75 degrees Celsius. Volume of acid was 10 centimeters cubed for each. The time of reaction was 15 minutes, so I kept the same for all of them. So, of course, acid, we've got tartaric acid, which we have done second. pH about I got was 0.8, and it took 58 millimeters, not centimeters, about there. Yeah, 58 millimeters of the diameter up of a balloon. And we've got acetic acid, which is a pH 1, which of course is a bit lower in acidity, despite maybe looking low on a pH scale. And that's got 55 millimeters. So we can see that those results do match correctly. With correlation, we have got the acetic acid being rather quite a bit of a pH, and of course, even though it looks like small millimeters, quite a lot more hydrogen that's in there in comparison. If you left it on the time, you see the gap being more large. So, which one's stronger, which one's weaker? I'd say from this experiment alone that the stronger acid is going to be the acetic acid. No, of course it isn't. It is the tartaric acid, which is stronger due to being a larger diameter. For balloon that was taken up, and of course also the pH that I measured at the beginning. So I hope you enjoyed this experiment. Has been less time since there was an upload gap from last time, so I hope you enjoyed the video, despite it being completely, not completely different to the last one. However, it took a bit longer this time, so I hope you enjoyed the video, and thanks for watching. Bye.